You load in your reference track and it's loud. It sounds punchy, clear, and void of artifacts. So you've got your mix there. You start driving your mix, making it louder, and then it gets to a point where it starts to break up. The sound of distortion. Not the good kind either. And I want to help you understand the process of what may be happening there and make your life easier on the tail end of finishing up a project so we can make things loud and avoid those nasty distortions. Now, I know how to make records loud and avoid those distortions. That's what happens after 8 years of mastering a ton of records. But I've never sat down to identify the moving components of how I'm achieving this. And I want to look at this objectively and measurably assess how you can go about this. So that's what we're going to explore today. And we're going to use tools most music producers and audio engineers have readily available. Actually, speaking of readily available, I know 74.3% of you are not subscribed. So do yourself a favor, hit the subscribe button and don't forget to tick the notification bell so my next videos are readily available for you to enjoy. Now, getting serious, let's settle on a common descriptor for the kind of distortion we're going to talk about and explore today. We're discussing unpleasant distortions, often associated with harsh digital clipping and overcompression. Now, these artifacts it introduces are not present in the original material, and it only happens when we push the loudness to the brink of breaking up. And this is an important distinction to make because digital clipping happens when digital signals exceed 0 decibels full scale, causing the peaks of the waveform to square off. Now, the distortion is the introduction of new frequencies into a signal not present in the original, and squared off waveforms introduce odd order harmonics. And if you've ever played a square wave tone, you're familiar with this. These are often harsh and abrasive, and often we don't want to be introducing these tones to our master. Now, there are some exceptions where hard clipping does pay off depending on the style, and it can be desired to get a little bit of that edge and aggression into a track. But for the sake of this video, we're going to assume we're going for clean, loud, and big. There are also other forms of distortion I'll briefly mention too, but I'm not going to go into detail. In harmonic distortion, such as intermodulation distortion and aliasing distortion. Aliasing distortion can be mitigated with oversampling on dynamics processors, and intermodulation distortion is something you should look into to understand how it occurs, and I might do a video in it in the future, but it rarely rears its head as a problem in mastering with mastering grade processors or plugins. Now, for the most part, managing loudness in mastering and preventing unpleasant distortion is a game of the following: good gain structure, transparent compression, techniques to increase your average RMS, being considerate of your tonal balance, and also finally how you set up your limiter. So for the purpose of this video, I'm going to be walking you through this chorus passage on the song I Wish You Well by Melbourne artist Jazz, and here's a before and after of simply slapping a limiter on the mix versus following what I'm going to present to you in the following video.
I wish you
You can hear the difference. One is crunchy as hell and the other one is still very loud but clean and open. So let's start with gain staging. Gain staging is when you balance the inputs and outputs of a signal as it passes from its source through a processor, through a bus, into another channel. You're balancing the input and output so it is consistent across the board. So this mix here, when loaded up, has a peak level of negative 0.2 decibels full scale, and that's going to leave almost no headroom to further process this signal without the risk of internally clipping and going over 0 decibels full scale. So as good practice, I always gain stage the source to negative 6 decibels full scale. There's nothing special about this number, it just gives me a lot of headroom to work with, and I'm going to show you why this is so important. So what I've got here, I'm going to just bypass my chain here for the sake of this discussion. Mute that, get that across there, there we are. I'll mute that there. Okay, here's a sine wave at 1 kilohertz. All right, let's play that through. Okay, sine wave at 1 kilohertz. Now that's at negative 6 decibels full scale, and I've got an EQ here. I'm going to make it negative 6 decibels full scale as well, as in 6 decibels full scale. So we're going right up to the ceiling where it is there. And if I bypass this and put this EQ in, the sine wave is still going to be clean. It's not went over 0 yet. However, if I make this 9 decibels, can you hear those harmonics? Oh, geez. I just unmuted my speaker to hear them. They're there. They are loud. And all that is going over 0, squaring off the waveform, and that hard clipping introducing those new forms of harmonic distortions into the signal. I'm going to turn that off. That is horrible noise. And so that's the first reason why gain staging is so important. You want that headroom. The second reason is because many analog emulations, like I use Vertigo VSC2 sometimes and the SSL channel strip, they react in a non-linear fashion to the source material based on the level of the input. And I went into Plugin Doctor, I've done it in other videos, where I bring those analog emulations in, run sine waves through them, and assess the amount of harmonics that they introduce or the way they react. And basically I've found -6 decibels true peak gives me the most useful point of reference for when using these analog emulations for consistent and best results. So those are two use cases for properly clip gaining and giving yourself headroom at the start of your mastering session. By just simply doing this, by simply taking this clip and bringing it down 5.8 decibels, we've made our way into mitigating any potential unnecessary distortion. Okay, we've mitigated that simply by just giving ourselves headroom. That is where you should start. I know that is simple and it's not as complex as some of the other things we're going to get into, but it's a foundational element of mastering is just gain staging. And we're going to do this between every processor using this true peak value here, this true peak point here, which will be -6 decibels true peak. The next thing you need to be conscious of is managing your compression time. If clean and transparent is what you're going for, I've found, and I've also discussed this in two other videos before, that when a gain reduction circuit's charge and discharge time, so their attack and release times, move faster than one cycle of the lowest fundamental frequency in a signal, harmonic distortion is more likely to occur. That's where you get those sort of aggressive sounding compressors and that sort of pumping that almost feels like it's on the verge of just edging over into hard distortion. And basically, that's just a complex way of saying loud bass, fast compression equals distortion. So how do we mitigate this? Well, we want to make sure we dial in compression times which are slower than one full cycle of the lowest fundamental frequency. And in this track, the lowest fundamental is 30 Hertz. So 1 divided by 30 equals 0.033 seconds, which is 33 milliseconds. I do another, my last video I just put out was all on audio maths. There were 3 really fundamental equations you should know, so you can go check that out as well. So basically 33 millisecond attack time, that is my charge time, and 33 millisecond discharge time. That's where we can start with for this process. And what we're going to do is I'm going to A-B two versions. I'm going to A-B two versions, one that is very fast and one that is very slow. Transients are much cleaner on that 33-second version, okay? 33 millisecond version, sorry. With that slower compression, that slower release, it's allowing that low waveform to fully envelop or fully go through a cycle before the gain reduction circuit starts to kick in. Now, there's one thing I haven't done here, which I hope if you've been paying attention to in this video, you would know we should be doing post this processor, because a signal has come in at a certain level and it has to leave at the same peak level. So what we're going to do is we're going to go back to this maximum true peak value here and monitor the peak value. So what level are we at? But don't think it was in my mind. Okay, so we've lost a little bit of gain here. We've lost 1.5 decibels of gain at that true peak because of the amount of compression going on. So let's bring that makeup value to 1.5 decibels and make sure we've got a 6 decibel true peak going in and going out. But don't think it was in my mind. Okay, so fundamentally, we're there. It's just simple as monitoring that section, seeing where the peak level is, and then making up that gain. As a side note, gain staging between compressors and having consistent volume from one process to the next also just makes for good style and practice. So if we ever bypass the compressor or bypass an EQ or wanted to swap their arrangement in which order we put them in, the same amount of gain will feed through the chain at every point and make it easy to recall, to move processes around, to make changes on the fly without compromising the overall level or the way our information is passing through that signal chain. Now, the next tool we have in our toolbox to increase overall loudness in a master is something I use more often than downward compression, and that is upward or parallel compression and clipping. It's a simple setup which anybody can do, and it yields really great results, because what we're going to do is we're going to compress the hell out of this signal. Okay, compress it really hard, clip all those peaks, make sure we just got the thickness of what's there, that low level information, the sustain of everything, the weight of everything, and then blend it back up underneath the original signal. And what that does is it increases the volume of the lower level detail. It gives us a higher RMS reading, or overall perceived loudness, or loudness in general, and it doesn't compromise the peaks or transient details of the original mix because we're just blending it into the original mix we've got there. So what I'm going to do is I've got this compressor set up and this soft clipper set up here, and I've got this parallel chaining, but what I'm going to do is I'm going to bring the volume all the way down, and I'm going to slowly blend it up and into the overall mix, and we'll hear it just slightly get louder without increasing the overall peak volume too much. And then what I'm going to do is I'm going to bypass it for us to listen to.
I wish you heard. I wish you prayed. I wish you heard.
To gain stage this, it's a little bit more difficult, or a bit different the process. I bust this out into a clipping and limiting auxiliary channel where I have a trim value and I can control the amount of input going in there. So if we look at our peak value on this loudest peak amount here,
But don't think it was in my mind. But don't think it was in my mind.
it's at negative 4.3. So if we trim negative 1.7, which I got there, we'll get to negative 6.
But don't think it was in my mind.
Okay, that is consistent volume, okay, as in consistent peak volume going through the chain. So upward compression or parallel compression helps increase over all RMS. If you're conscious of the settings I'm using here for the compressor, relatively moderate attack time, but very slow release. If you have a fast release on this parallel chain, you're going to hear it pumping in the background and sort of warping the dynamics and the sustain of everything. So slow release, moderate attack, and then quite a lot of compression. Moving on from these series of dynamics processing and clip gain and gain staging, one of the most important aspects of loudness is actually the way we perceive various frequencies. And you've probably seen this before, the Fletcher Munson curve, and it plots out how sensitive our hearing is at different frequency points. Now, just because I'm showing you this graph, I'm not actually giving you a license to try and transfer this curve onto your masters. All I'm trying to do here is start a discussion where we can start to think and be conscious of how relative points of energy in a mix balance with one another and how that translates across to a listener. Now, with this mix specifically, I'm going to play it through and you're going to hear this. The upper mids and the top end feels a little bit lacking. There's a lot of low end, it's quite spacious and sparse, but the top end doesn't really carry itself very well in terms of there's not a lot of brightness to it or openness to it, which if you're listening to it can help with that overall loudness. Now, if I were to say there was too much low end, I think the low end's quite dialed in right compared to the vocal level. I just think tonally needs a little bit more top end. So actually let's have a listen to this and be considerate of how we can help this just open up in tone and be a little bit better balanced.
I wish you heard. I wish you prayed. I wish you heard. I wish you prayed. I wish you heard. I wish.
Now, I know that's quite a liberal boost, 2 decibels, and it's good for the sake of showing you an example how this works, but it also just brings a nice breathness to the air, allows the hi-hats to be a little bit more sharper against that really deep bass. There's just a 2 decibel shelf there. Now, that's not to say every mix you get, put a 2 decibel high shelf there, and then you're going to have a louder master. No. Again, like I said, it's about being conscious of how the top end, the low end, all the different frequency ranges balance against one another and making decisions based on that. Now, the next one is going to get you a bit weirded up because I'm going to say we're going to use intentional clipping to avoid distortion. And you're probably saying, avoid distortion, but we're going to clip it. How does that work? Well, yes, you heard it right. If we because we've been gain staging this whole time, we know where and what our true peak values are. And we can actually control the amount of clipping and headroom we buy ourselves, thus creating a ceiling to which we can set a limiter to. Basically, we know where our peak values are because we've been gain staging correctly, and we can control the amount of clipping, which means we can control that amount of potential distortion or artifacts to be introduced, thus mitigating how bad it could potentially get if we didn't know where they were. And I'm going to get started on this discussion by showing you standard clip and using the soft clipper, but I'm also going to go out of my way on this video to admit I was completely wrong about the way standard clip worked. William Fields, on another video I did, made a point about how the soft clipping function worked in standard clip with saturation mode boosting into the ceiling for a rounded soft clip transfer. Now, this is a really good way to mitigate the introduction of excessive harmonic content while bringing up the overall RMS value of the signal. Now, I'm going to apologize there to Will because I was wrong about that plugin and how it operated. So hats off to you for pointing that out and highlighting that out in the comments of another video. I appreciate you, and I'm sorry for getting that pretty wrong in my last video, but I'm happy to make and admit when I've made a mistake. Now, before I show you this dialed in, I'm going to show you the oscillope view and the harmonic structure. So here is basically just hard clipping because I have no soft clip saturation going on. We can see in the oscillope view that it's just a hard clip, straight at the top, a big dirty square. All right, let's zoom in there. There we go, just a square. And what's actually happening is it's just introducing an infinite amount of harmonics up until every octave, up until the end of the bandwidth of the sample rate. Now, if I swap this over to a B version, okay, if I swap that over to a B version, you can see that that the harmonics drastically fall off in the top end, actually below the listening threshold there. So if we go over to our oscillope view, we can actually see what it's doing. It's rounding off, it's soft clipping and transferring into that flat top a bit more smoothly. So I'll just show you the A version and the B version. So that's why we use soft clipping instead of hard clipping. And this whole time, whenever I've been using this plugin, I thought I was soft clipping, but I actually was absolutely not. So Will, thanks for pointing that out. Appreciate you again, and I'm happy to give you my sincerest apologies for when I've cocked up there. Now, in terms of setting up our clipper, we're very lucky. We have been, and you have been following this and doing correct gain structure throughout your mastering chain, making sure your peak values going from one processor to the next are consistent. And in this circumstance, -6 decibel true peak is where we've been at. So if I want to clip this 1.5 decibels, all I need to do is drag this clip value down to 7.5. And that's going to give me 1.5 decibels of clipping. Now, without this soft clip saturate, it's just hard clipping. So I've dragged this up to about 50%, and that's going to allow us to clip this signal. Now, the output, this is my bad habit. This is my personal bad habit. I hope you don't take on, is I tend to set the gain of my clipper to -1 decibel output. I advise against this. This is just the way I tend to work, and I'm happy to show you my flaws as well as the things that I advise you to do. I would advise to keep this at 0, so that way you've got a -6 decibel true peak going into your limiter. And the benefit of that is if you're ever going to swap out your clipper, that you have consistent gain structure throughout. This is just the way I set it up because of bad habit. So with that, that means that at this peak value, I've got a -1 decibel true peak going into my limiter. For yourself, maybe -6 if you're going to start practicing well, unlike me, who has a few little bad habits, and I'm happy to sort of expose them along the way. So this, where are we? Not the limiter, I want to look at this. There we are. My peak value here at the loudest point should be -1 decibel.
But don't think it was in my mind.
Perfect, -1 decibel true peak. Now, with that said, we're going to dial in our limiter. Now, our limiter, these 3 parameters are what we're going to focus on. I'm going to drive it quite hard, 4.5 decibels, so I can show you how far we can mitigate very heavy limiting and avoid distortion. We've got 3 parameters. The release time. Okay, the faster the release, the more distortion, because it's going to be moving faster than the lowest cycle of a fundamental frequency. Now, the attack time in ProL2 is a gate for hard clipping. So the slow, very slow attack, that's just going to be clipping. Very fast attack, it's only going to be a limiting stage. So dialing this in is very important In fact, you could just go to 0, but it tends to kill too much of the transients just having the limiting stage there. But we're going to start with a completely distorting. The look ahead is basically going to allow the gain reduction circuit to look ahead to the incoming signal so it can anticipate any loud peaks or swells in volume. That's also going to help mitigate any potential digital clipping. So with this all said, I'm going to have a very distorted 3 seconds or 4 seconds of audio playing on loop, and we're going to dial in these parameters to finalize this master.
I wish you. I wish you. I wish you. I wish you. I wish you.
Now that's all dialed in, I want to listen to this before and after at the loudest short-term reading of the track. The loudest short-term LUFS reading of the track is that loop I've been doing where it all distorts and goes crazy, because that has the highest LUFS value of any point in this track. Both of these are equally as loud as one another, so it's going to be fun to hear them, and we can definitely hear which one doesn't have any of those nasty artifacts and distortion anymore. They're both equally as loud, and we've got a good result at the end of the day.
I wish you. 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 I wish.
Now, as you gear up to start implementing some of these techniques, it's important to take the time to consider how any one of these may impact the dynamic and tonal composition of your music. And in my Mastering for Producers course, I share more in depth on topics just like this, like crafting your low end or how to optimize your listening environment. And the problem with YouTube is I can only ever do 10 to 15 minute videos, because not everybody here wants to watch 7.5 hours of in-depth mastering content. Whereas this course gives those of you interested the opportunity for high level and accessible information. Now, if you can't tell, I'm just really excited about this course because I spent the better half of 2022 developing it, making sure that all the lesson plans didn't just draw on my knowledge, but were also supported by research and references and peers reviewing my course content. Now, currently it's on sale, and there's a link in the description if you'd like to check it out. Otherwise, if you need another quick fix of mastering content, click on one of these suggested videos and leave a comment below to let me know what you'd like to see next. Thanks anyway, and take care.